Good afternoon. I hope you're ready for a challenge, because I will tell you the story in a way that you can think together with me, hey, what would I have done in this case? If you see the data, you can make your own mind up, well, oh, this could be the problem. And then later on IRC, you can say, well, Frank, I already knew what it was at slide 3. Yeah? So to tell you this story about the bit flipping, it helps to know a little bit on what we do and how the network works, so that comes into play about how we actually experienced an issue. So what we do at Certified Secure, we do computer security training. We train engineers how to do computer security by having them hack into my systems. If you can hack into my systems, with a little bit of help, then you know the problem of security, and then you can look at your own systems and think, oh, I need to make some changes. For this, we have hundreds of challenges, and each challenge consists of multiple virtual machines. And they break all the time, because literally we're giving away shells and such on those systems, and yeah, people are hacking it, it will break. So for that, we have something that is testing, but is different testing than what most developers do. Instead of looking at the load and the disk space and those kind of things, what we do is we run a browser that actually solves the challenge by logging in, doing all the steps from the endpoint. So we mimic all the actions of an actual user, all the way until you get the green 100% pop-up that shows you, yeah, you've completed the challenge. We do this for all the challenges continuously from some Selenium farm. And if that fails, and then we get into the autonomous systems from the previous talk, if that fails, it will automatically reboot all the virtual machines that are associated. If that then still fails the test case, it will restore them all to a known good backup. Run the test again. If that fails, it will reinstall all the virtual machines from Git. Run the test again. If that fails, then I get a call, or whoever is on call. And to understand that bit of the story, so on call, I think many of you are on call regularly, and I used to have a ringtone that was like a nuclear alarm. That was not nice, middle of the night. So now we've switched it. Let's see, here you go. Let's hear it. It's the sad trombone. The good news about this is sad trombone is much better, and it tells you exactly what's happening. So that's my tip for everybody. Use the sad trombone. Even now, if I'm at home and I drop a glass of tea, then one of my kids will be from the other side of the room like, whap, 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 sing to me. So the story starts here. Think together with me. As Bert has predicted, at 3 a.m. on a Wednesday night, literally 3 a.m. on a Wednesday night, I was awoken to an orchestra of sad trombones. Not one, a whole orchestra of sad trombones. That's not what you want to hear in the middle of the night, even if you're not on call. That's not something that's nice. So things are bad, and of course you log into your systems and you try to figure out, okay, something is wrong, let's investigate. And this is where all the graphs are useful. You look at the network traffic, oh, fine. CPU load everywhere, fine. Disk space everywhere, fine. No issues, even worse. I can, of course, run those tests myself. So if there was a challenge that was failing, I would run that test case again, and it would be fine. But then another one would be failing. Okay, let me run the other one. Oh, now it's fine. And then another one, and it was one of those tricky problems. So that's not good. And the starting point might be the most difficult thing. You need a little bit that you can pull that thread and do your investigation. You need something. You cannot do, random things break. I don't know. So I was looking, and no disk errors, and nothing hardware related. At some point I saw that one of our load balancers had some health check failures. So if you have a load balancer, it is on TCP level, doesn't really matter. But it will every second check if the backend is alive. So if you have 140 errors in an hour, that means that well, a small percentage of those health checks were failing. Didn't know if this was the issue, but at least it's something wrong. But I think many of you know this problem. If you start investigating some problem, you might find something that's wrong. Turns out to be completely unrelated. So yeah, so then you chase that, and yes, it is still wrong. But I did not know at this moment, is this the issue? So, okay, let's pull this thread. Let's have a look. How do I replicate this error? Well, if it's a connection to some backend, how about I just loop and do the connection to the backend, right? Loop, loop. Anyway, okay, hang. And then okay. Sometimes it would hang for a few seconds. Interesting. I have no idea what it is. I would understand if it always works. I understand if it never works. But randomly sometime, that's bad. So I investigate and I look at the firewall. And look at the log files. And I saw some errors there, drop packets. So think for yourself, what's the logical next step? It's going to be a PCAP, right? At least for me. Yeah, you can say on IC, Frank, of course, it's completely different. But what I did, look at PCAP. So look at this. This is one connection that hanged. I'm going to give you a few seconds to look at it. Think for yourself. Do you see the issue? Yes, there is an issue. It would be funny. Oh, there was no issue here. There is an issue. And you will see it there. 2 packets. And you can see from the timestamps, there's 5 seconds between them. But from this PCAP, they look identical. But if you know, exactly, retry. But if you know about TCP, the retry should have been 1 second. And then 2 seconds, and then 4 seconds. But this was 6 seconds. Weird. Something is wrong. We know there's something wrong. I looked at my log files, and the firewall said drop packet. That was the packet that was dropped. But if you look at the firewall, at least on IP tables, it is really weird if it drops a packet in the middle of a connection. It's very normal to drop the packet at the beginning. I'm not liking this connection. But as most of you will have, the first line you have is state related established, we accept. And then we only focus on the new connections. This is you put this one on top, so it's the first one to go. So I did not understand why is the first packet dropped and the second packet is accepted. What's the difference? Why? Looking more, and then I thought, well, it has to be something with the state engine. Turns out you can add some debug logging to add some debugging of the state engine. Sure. So I enabled that, and yes, I see this. So the connection tracker, state engine, finds out bad checksum. Oh, well, that would explain why the firewall is dropping the packet. And then the other packet, 6 seconds later, does not have a bad checksum. This was, now, I think it was already 9 a.m. It's going to be one of those days, right? This is not looking very good for me at this moment. And especially since this was between 2 different locations. So I needed to figure out, is it me or is it not me? It's a very important distinction. Think for this for a moment. Would you like it to be you, or would you like it to be not you? I prefer it to be me, because then I can fix it. But we don't know. So we have 2 different locations. What do you do if there's a checksum? You start a PCAP on one location, see the packet going out. You do a PCAP on the other location, see the packet coming in, and you play spot the difference. Yeah? So far, making sense? At least to me, this was logical. We're now at 1 o'clock in the afternoon. So, got the got the PCAP on side A, side B, sending it to side A, receiving it, 2 PCAPs. So send at B is on the left side, received at A is on the right side. Vimdiff, very nice tool, because otherwise you would be looking at a very long presentation here. Vimdiff tells me exactly something is wrong. And I can see from the red, we send a 1 and we receive a 0. Everything else was identical. But if in the middle of this packet you change a 1 to a 0, then obviously the TCP checksum header field is going to fail. Okay, it is not me. The furthest part that I sent it out, I sent it out correctly, I receive it, it's wrong, something in the middle. But in the middle is the internet. It's going to be a great debugging session, this. I could, at this moment, send a ticket to our data center. We could send a ticket, dear data center, this is the data center of where we sent it, that is location B. Hey, dear data center people, someone is flipping bits in some of the packets, please fix, love, Frank. That's going to be a great ticket, can you imagine? You get this ticket, now what? And of course you could say, well, since I have determined it is not me, let's leave it at this, but, well, you all know how the world works. It's not gonna happen easily. They're not gonna jump on this, oh, we're gonna put all our resources in this. So I wanted to do a bit more investigation. And where do you start? At the IRC of NLNOG. This sounded to me like the best place to get some insight, because I had never seen this behavior. Some of you may have seen the behavior, but I had never seen it. You send a packet on one end, you receive it on the other end, and some bit was flipped. That made no sense to me, and I had no idea why it would happen on some packets, but not all of them, some connections. And to make things worse, normally with TCP you would have a retransmission, right, within a second. The retransmission would also have a bit flip at a different place. So that's why my testing would fail, because it would hang too long. The challenges would not be completed quickly enough. But sometimes the connection, I was sending like gigabytes of data, no bit flips. And then I do one other connection, and I have bit flips, and in the retransmission I have bit flips. Made no sense to me. So I need help. NLNOG, wonderful place. And yes, I am Haakjes on IRC. Hello, everybody. Yeah, now you know who I am. So I got a lot of help, a lot of insight. Some people actually called out the issue already, like, okay, I think it's going to be this and this. But obviously, one of the problems is, where is the issue? Right? We need more data. And for this, think for just a moment, how would you continue this? You can now send another ticket, but it's not going to help. So I decided it would be best to make it easily testable. So make a script so we can show that the problem exists. But how do you show that the problem exists? Well, what you could do, if you have HTTP, you should be like, blah, HTTP. We do HTTPS. HTTPS much better. Yeah? So if you send an HTTP request, you get a redirect to HTTPS. So if I go to a server, I call it B, it would be a bit too confusing otherwise on this slide. And I say, I want to go on HTTP to /AAA, lots of A's. Then the server was going to respond, please go to the HTTPS version and put in the path AAA. And now I know that the server sends to me a whole bunch of A's, and I can see if I actually receive A's or if one of the bits is flipped in the response. Because now I have a known response from the server. And I can do this to servers of other people. And that's helpful because I already know that my servers have the issue, but I wanted to know, is it me or More, not me, yeah. Just me or not. So if you then look at the response, and you have to look with pcaps, with TCP dump, because at the TCP level, if you do curl will send you the response, but then the kernel is already going to drop the packets with the broken checksums, or perhaps your network card will drop the packets with hardware offloading. So in this case, I was able to see the bitflips in the pcap. And I've spoken for just a second. I hope by now you've seen it. It is right there. So for those of you on the IRC channel, I think for many days you have seen pastes of AAA at AAA on the IRC channel. This was it. So we need to now figure out what's going on. We know we have bitflips. I had a few locations. I know from DC2, which used to be Access for All, it's now KPN. That is where the servers were for me. And I had a test point in OVH, and I could see the bitflips between those locations. I had a test point in TransIP with a VM. I could see the bitflips in there. I also had a system with A to B internet, and there, no bitflips. Didn't matter how many requests I did. So the bitflips are not always. And if they are not in all the connections. It's going to be a really difficult problem to solve. So let's do a little checklist. Is it just me? I know my servers have this issue. Not to everywhere, but to some locations. I also knew of another customer that was in that same data center. And I could do the test against their website, and I could see the bitflips. So I know it's not just my rack. It could be the entire data center. Possible. But the next step up, could it be even bigger? Could it be the entire of KPN? So how do I test that? I need to find another website that's not in the data center of DC2, but somewhere behind the KPN network. So you go to DNSlytics and you say, well, for this AS number, who are the top websites? Which one would you pick? I know which one I pick. I thought if somebody's flipping the bits of Bert, he might be a bit annoyed with that. It might be a good ally to have. So let's see what happens if we do this against berthub.eu. Bert has multiple uplinks, but since I knew the IP address of the KPN version, I could go directly there and yes, do you see the ad? It's there. Okay, so it's bigger than the data center. We know it is at least bigger than the data center. There's also KPN, bigger network. Could be even bigger. But if we now look at the at how the things work, some routes have the issue and some routes do not. Next step, better testing. Let's make sure that everybody can run the script and get some data. So we invented bitflipper.sh, a shell script, and everybody was running my shell script. If you don't know me, my background is in penetration testing, hacking, memory corruption. Let's run the shell script from Frank with root access everywhere. Yes, a good plan. So, cool things in this script. It records trace routes, TCP, and ICMP, because those routes could be different. It sends 1,000 HTTP requests. It does the PCAP. It searches for the ad. It will upload all the results to a 6-spaced URL. And then you would have a 6-spaced URL. You put it in the IRC chat, and it's a really easy way to share the data. And this was all the 6-spaced URLs you were seeing for many days in the IRC chat. Yeah. Okay. Would look a bit like this. You have a whole bunch of trace routes. And then you would have the actual packet dumps in there as well, the offending packets. At least we have a very clear problem. So findings so far, we know fiber to the home of KPN has issues. We have also determined it was going to freedom. Everybody was running the script, so we got lots of data points with it. And this was also where we could talk to the KPN people, like, I think something is wrong. We're still not sure where it is, but we're going to need some help here. So they were now also involved. And it's really difficult. Those two routes, both of them had issues. But good luck figuring out which hop has the issue. I couldn't see it from this. And what we need is more data. More data. I don't have to tell you how wonderful the NLNOG ring is. It is amazing. So I got access, and I was able to run the script. And from the 685 nodes at the time, 77 of them found bitflips. Those are them. I was not able to determine a pattern, but obviously KPN was, because they know exactly how things are connected. They now have a pretty good idea of where to look. And this would not have been possible without the ring network. So we have the community, everybody working on it. We have the ring actually being used for that. This is wonderful. This is good stuff. This is the good data. So, yeah. By now, we should be able to know the issue. What do we have? We have bitflips on some networks and not on all of them. If a path have bitflips, I could calculate about a percentage and a half of those TCP/UDP connections would have the bitflips. And if that connection would have the bitflips, 5% of the packets would have bitflips. And the bitflips would happen at the same location in the packet, but not all packets would have using the same location. This was enough information to figure it out. Think for a moment. And for KPN, this was their moment. Okay, we're gonna do some A/B testing. We're gonna switch some routes. We're gonna figure it out. But I wanted to make sure that we had a statistical good test that was quick to run, because if you're going to switch large amounts of traffic, it's better to have a test that is pretty quick and you can trust. So my working theory is this. There is some kind of link aggregation that chooses which port to use based on layer 3 information. That's why some connections would have issues and some do not. I would think that one of those links would have an issue, and I'm thinking bad memory because you write a 1 when you put in the packet, and when you read the packet, it reads a 0. That was my theory at the time. So we made a bitflipper Python, because that's the next level from after shell. And this one, I'm going to give you the percentages as a homework assignment to see later when the slides are online. But basically, we send 60,000 packets, and we do 400 connections, 150 packets each connection. And I, with a lot of pain in my head, I got to a percentage of a 0.23% chance that we would see no bitflips if there was actually bitflips on this path. I checked with 3 people the statistics, and they all gave different answers. So, okay, this was it. Now, with the friends in KPN, we could do switching. Think of it, we joked about this at the beginning. KPN is going to do a binary search on the network. Okay, they didn't do a binary search, but with this tooling in place, the ring nodes in place, they were able to test from multiple locations. They were able to quickly pinpoint, because they knew which 77 networks were seeing the problems. They already had some ideas of where to go. So you do a binary search, and then finally, the ticket, I did send a ticket at some point, was resolved like this. So for the bitflip issue, there was some packet loss, yes, of 2 weeks. Important things here. The NLNOG community was very active with this issue, and somebody wrote test scripts, and the NLNOG ring node network was used to reproducing the issue. And it was run on so many networks, so many nodes. In the maintenance issue, we were able to, by switching a lot of traffic to redundant path, to isolate it to one single 100 gigabit port. between the KPN and the NLIX. They reloaded the line card, problem went away. Yeah. So yes, one of the links on one of the internet exchanges, it was quite a large link, but of course on the scale of KPN you have many of those. That was indeed the issue. Some lessons from this. I really recommend you test your production load from the point of view of the end user, because I would never have detected this issue if I was just looking at ping or things that I know. You have to test for the things you don't know. And one I really recommend, continuously test your production environment from what a user would do, because then you catch all the weirdness. That's my advice. My other advice is use the sad trombone ringtone. Yes. Make the problem repeatable, visible, and impossible to ignore. It is very important. If you have weird stuff, spend the time writing the scripts, because then, if you have a community like the NLNOG, they will jump in, and somebody else can verify your scripts. For at least a week and a half, I was convinced I made a typo in my script somewhere, because it was so insane. And I think if you have problems like this, without the community, without a ring network, I don't think it would have been easily fixed. This is such vital infrastructure, so I'm really happy that it exists. So thank you all for that.
Well, Frank, thank you for explaining the BitFlipper story to us in full detail. This has been haunting the community for, more or less 2 weeks.
Yes.
Yeah. And I'm sure there are many people who want to share their experiences or say praise or complain about the holes that they found in your scripts.
Obviously, yeah.
Or something else. I don't know. Go ahead, please.
Hi. Joris, een mooie KPN. I've been doing this work for like 25 years. This was the best ticket ever. Normally it's closer to your first mail. Something's broken, please fix it. And well, this was on the plate. The timing, you were in bad luck because it was right in the middle of the European Football Championship and the Olympic Games. So at KPN we have a network freeze to prevent bad stuff from happening. So it took me a little bit of time to arrange a maintenance window to, well, you want to do what? Shift a few terabits of data left, right, just to see a bitflip. But we managed it, and with the reproducible data and Bert's server and all the stuff, the NLNOG ring really came in handy, really handy in this. It would otherwise be very hard to investigate, I think. So thumbs up for the NLNOG ring. Thank you.
Well, thank you for your feedback from the side of KPN as well, Joris. Rinse.
I have a question to you. How many bottles of wine did you send him to thank him? Okay. Just another question. When can we see the ring bitflipper appear on our NLNOG ring nodes?
So there is a tool called Ring Quality that has been developed. I am developing it. As soon as I'm ready with it, I will put it in the repository, so then hopefully it will be deployed everywhere. It does a bit more than just bitflips, but basically it is doing this amount of connections, this amount of packets, send them back and through, because especially at larger scales, when you have so many redundant paths, you can't do just test over one connection. I think that was the main takeaway, the lesson for me, that you have to test it multiple connections. So that script is written. I just need to figure out how to deploy it without root permissions to do the PCAP stuff on the ring nodes. But we'll figure it out, and it will be on the repository there.
Okay, that's very nice. Thank you.
One last question from Mike.
Not a question, a comment, and not really for you, but it seems like the NLNOG ring is very useful. So I suppose any other tier ones in the room, and I'm here independently, I made my own badge today, Any other tier ones in the room would really benefit, I guess you'd say, from having an NLNOG machine somewhere.
Please.
Not looking
yeah.
anywhere in particular.
That's a very valid point because, yeah, my network is not the biggest one in the country, but every now and then I do have to debug something, and it is always wonderful to find that the network that you want to debug with has a ring node, and it's always a bummer if they don't. So please join.
Yes.
All right,
Okay.
Frank, thank you again.